Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahin bin Salami. So today, me and my team present about our subject, which is artificial intelligence. So our title is predicting transaction time between QR payment and cash payment. As you can see, our group contains three members, which is Sarin Haikal bin Muhammad Zarafullah, Muhammad Shah Zafri bin Muhammad Rizal, and me, Muhammad Zahid bin Salami. So, I will pass to Shahir.
I will explain about the background of the case study. For the first one is the rise of a cashless system, rapid growth in the QRP and e-wallet across the campuses, food court and public hunter. And the second one is the need for speed. In high traffic environment, efficiency is a top priority. And number three is the bottleneck, even a minor delay result in long queue, user justification and operation inefficient. And the last one is the data. Study use a real-world metric, signal strength, payment method, and user demographic. Okay, I will explain about the methodology why linear regression. Modeling relationship is a predict a dependable variable transaction time based on the independent variable. Like examples is a signal strength. Key advantage of using the linear regression is interpretability, consistency, clearly show how much each factor impacts speed. Number two, efficiency, iaitu low computational cost, ideal for a small to medium data set. And the last one is a baseline model, provide a solid foundation before moving to the complex AI model. And the last one is significant, offer a transparent why behind the black box prediction. I will explain about the project objective. For number one is the predictive modeling. Develop and evaluate a machine learning model to estimate transaction duration. And the number two is features analysis, which is to identify the most influential factor. Example, does signal matter more than the payment method? And the number three is performance assessment. Determine how accurate a linear model can represent real world transaction behavior. And the number four, or lastly, is a practical insight. Provide the actionable data to help service provider improve payment system efficiency. Thank you.
After training our model, we were able to derive a specific mathematical equation that predicts exactly how long a transaction will take. This is the secret formula behind our analysis. Looking at the equation, I want to highlight three most impactful numbers. First, internet signal or X5. This has a large negative coefficient of negative 16.7. This is our most significant finding. It means that for every single bar strength that you gain, the wait time drops by nearly 17 seconds. This proves that network infrastructure is the biggest bottleneck. Second, number of item X1. This has positive coefficient of 10.3. Effectively, every single extra item a student buys costs the queue about 10 seconds. Third is the payment method. We found that using QR codes or e-wallets in our average 7.2% faster than using cash provided the signal is stable. This equation allows us mathematically prove that the internet is more efficient than changing payment methods. For our result, we first evaluated how accurate our linear regressions model were. We tested it on 20% of our data. Our mean absolute error was 6.6 seconds, which is quite good for manual study. It means if the AI guesses 20 seconds, the real time is usually between 14 and 26 seconds. The R square score was low, but this is expected because human behavior in queues is unpredictable. Our model generated a mathematical equation to predict wait times. The most surprising finding was the coefficient. Internet signal has the strongest negative impact, proving signal by just one bar cuts wait time by nearly 17 seconds. We also found that the age has almost zero effect, disproving the myth that older users are slower. The real bottleneck is the network, not the person. This graph visually confirms our equation. On the left, you can see a steep downward slope. As the internet signal goes from 1 to 5, the time drops drastically. On the right, the line for age versus time is nearly flat. This visually proves that high wait times happen to everyone, young or old, if the connection is bad.
Okay, next we go to discussion and key observations. So, firstly, technology over demographics. Technological factors like internet, signal, and payment method have a significantly higher impact on transaction speed than user attributes like age. After that, infrastructure is critical. The strong inverse relationship between signal strength and time confirms that system efficiency depends heavily on stable network connectivity. And after that, model strengths. Linear regression provides a clear, interpretable baseline that identifies exactly which real-world factors cause delays. And lastly, linearity limits, which effective while effective, the model may not cause complex nonlinear human behaviors like a user forgetting their password or fumbling for cash.
Last but not least, I will explain about conclusion and the summarize or the summary. For this project, I will summarize and conclusion for this project is the objective achieved. The study successfully developed a linear regression model to predict payment house transaction time using a real world data. And number two is a primary finding. Improving digital infrastructure network quality is a more effective at reducing queue than focusing on the user related factor. And the last one is a value of the model. Linear regression is a powerful analytical tool because it is computationally efficient, easy to deploy to the low resources post system and highly transparent.
So, lastly, we go to future hope and reflection. So, our team maybe do this thing in the future, like study limitations of our project. The current model assumes linear relationships was trained on a structure but smaller datasets. So maybe in the future we will find a bigger and larger dataset, so our project might be more effective. And after that, future research. Explore nonlinear models like random forest or neural networks to improve accuracy. As you can see, random forest and neural networks are very accuracy to find some to optimize a point. And after that, expand the dataset to include diverse environments and more varied user behaviors. And personal reflection, this project provides hands-on experience in the data to insight pipeline, specifically in handling real-world challenges like data cleaning and outlier removal. So that's all from us. Thank you so much.